Hey everybody, this is the video that can maybe help you out if you get stuck on the review for Friday, April 3rd. Problems 1 through 6 is kind of taking the next step with our review of exponents. There's been a lot of stuff on exponents this week. And there's a little bit of everything here in problems 1 through 6. So you got to remember when you're supposed to add exponents together and when you're supposed to subtract exponents and when you're supposed to multiply. And then here, when I said we're taking kind of like the next step, I think I said that. But we're taking the next step with exponents, and like the new stuff for today, I guess, is going to be how you handle a negative exponent. Okay, like especially in your final answer, and that's kind of like what I suggest. Like I wouldn't really worry. Like if you get negative exponents along the way, just kind of roll with it as you're like adding powers or subtracting powers or whatever you're doing. Don't really worry about the fact that you end up with a negative exponent until maybe like the way end, and then at the way end you can turn the negative powers into positive powers. Okay, and then I'll show you that in a second. And then we're also going to talk about what it means to have an exponent of 0. So anyway, looking at the screen here, it was section 1.9 when we were looking at what to do with 0 and negative exponents. So kind of a reminder that in these situations, this is when you would subtract powers. 10 to some power over 10 to another power. That's when you subtract the powers. And so here, 10 to the 4th over 10 to the 6th, when you subtract those powers, you get 10 to the negative 2 power, because 4 minus 6 is actually negative 2. But another way to look at this is when you have all of these 10s, all these factors of 10 written out, you could say, well, doesn't this 10 divide with that 10? And they pretty much cancel out because they divide to be 1, because 10 divided by 10 is 1. And then same with this 10 and this 10 can kind of divide out, and then that 10 divided by that 10 and that 10 divided by that 10. So up top you're left with just 1. Okay, after all this canceling, up top you have a 1, and on the bottom you have 10 times 10, a 10 times 10 that didn't cancel. And so that's 10 to the 2nd power, 10 times 10. So you had like a 10 squared down here that survived the canceling. And so the bottom line here is, like the punchline, is that 10 to the negative 2 is exactly the same as 1 over 10 squared. Alright? And that's kind of what you're supposed to do when you have like a negative power. So here's another sort of even bigger punchline or bottom line. When you have a negative power, you can move or drop that base and power down to the denominator, and you can make that negative power into a positive power, and it'll still be the same thing. So like if you had x to the negative 5th power, you could totally change that into 1 over x to the positive 5 power. So here, so now some actual problems, and there's a little bit of work to do first, because here you have x to the 1st times x to the negative 13th. The first thing you would do is add exponents to simplify here. But now we're at the end, I guess. Not much happened, but we're at the end, and okay, so now I see that I have a negative exponent. So now you fix that for your, before you can say you have a final answer. So you move the x down to the denominator, and that negative 12, like magic, becomes a positive 12. Here, this is the situation where you would subtract powers first. And 7 minus 9 is negative 2. And then now it's time to make the adjustment for the final answer. Move the x down to the denominator. And what's left up top in the numerator is a 1. Okay? Here, something sort of interesting happens, or noteworthy happens. With the x's, you have like x to the third divided by x to the second. So again, we're subtracting powers. And then the y, same thing, 8 minus 10, that's where you get a negative 2. So something worth noting here and reminding you of is that the x has a positive 1 power, whereas the y has a negative power. So when you go to like fix the negative power or powers and you move stuff down to the denominator, you're only going to drop stuff down that has a negative power. This has a positive power. That x to the first stays in the numerator. It's not going to drop down. It's got a positive power. But the y, it has the negative power. And so the y drops down to the positive power. Okay? So I mean, on that note, I'm going to kind of go off on like a sort of a sidebar. And I'll even use different letters to help make my point. If you had like, well, maybe I'll use a number to kind of keep things consistent or whatever. You'll see I'm just kind of rambling right now. So let's say you had like 4. So I was going to use different letters. What's your favorite letter? I don't know, T, whatever. 4t to the negative, I don't know, 3. So again, this is like a totally random problem I just made up, okay? What do you do with 4t to the negative 3? Well, you have a negative power that you have to fix, right? But here's the biggest reason I'm showing you this, okay? What's being raised to this negative power? Is it the 4t, or is it just the t? What do you think? Is it like, is the 4 also being raised to that negative 3 power? The answer is no. This 4 is got a positive power of 1. The only thing being raised to that negative 3 power is the t. Now, another little mini sidebar, if we had parentheses right there around the 4t, and now it was 4t to the negative 3 power, that'd be a different story. But as it's written here, you would leave the 4 in the numerator and only drop down the t and make that 3 positive. You know what I mean? Back to number 4 here. Let's say you had like 6 and a 2, like these regular coefficients, these normal numbers of 6 over 2. Now, you would just straight up, just like always, you would straight up do 6 divided by 2, just like you would do in like 2nd grade or 3rd grade or something. So 6 divided by 2, that's clean division. We're starting off with like, I want to show you like this divides cleanly. So 3, and then you would do x to the third divided by x to the second, and you would subtract the powers, and then so here you would leave 3x, because really you don't need that power of 1, right? 3x in the numerator, and you would only drop down the y. Alright? Let's say it was switched, and it was like, or flipped, I guess. Let's say it was 2 over 6. Well, that's not clean division, but 2 over 6, you know, does reduce. So don't write it as a decimal. You know what I mean? Like, don't do the division just because it's not clean and just write a decimal. Don't do that. 2 over 6 doesn't divide clean, but it does reduce to 1 over 3. Okay? So leave it as a fraction. And then you could so do, okay, so that's 1/3, and then we have the x to the first, and then we have the y to the negative 2. And so now, when you go to address the fact that this is a negative power, and you also might want to just actually multiply all this together, like get this all together, you would pretty much say that the x, like see here, we have a numerator and a denominator already here in this fraction out in front, you know what I mean? So really what you could do is you could like leave the x to the first in the numerator, like with the 1 here, and then you could like drop down the y to the denominator, you know, like with the 3. Alright, so your final answer would be like x all over 3y to the second. Alright, and if this was like a fraction that couldn't even be simplified, like not only could you not, like let's say it was like 3 over 5, you know, 3 divided by 5 is not clean division, and it doesn't even reduce, so you would just pretty much leave it as 3 over 5, okay? Just these other examples are like, what about, oh, 0. Anyway, so examples like these are just, you know, just remember that you could also multiply powers, like you could, when you do powers to powers, you multiply, so this becomes x to the negative 12, y to the positive 18th. That's awful. I mean, it's always awful with this mouse, but oh god. Yeah, god. And then here you would like leave the y to the 18th in the numerator, but you would drop down the x and you would drop down the z. Here, don't forget that it's not only x to the negative 20th, but it was also 8 to the 5th, or like 8 to the 1st to the 5th, so like, jeez. And you would leave the 8 to the 5th in the numerator, I mean, or whatever 8 to the 5th power is. I mean, you can totally just leave it as 8 to the 5th, and you would drop down the x, and you could make it a positive 20. One more quick thing about these first 6 problems on your review is, what do you do when it's a 0 exponent? And again, there is a sort of at least a decent explanation why that we could do, but bottom line, whenever you raise something to the 0 power, you always get 1. Whether it's x to the 0 or 3 to the 0 or, you know, 50 to the 0 power or w to the 0 power, you always get 1. So like here, you know what I mean, like you add the powers, and 13 plus a negative 13 is 0. But you wouldn't leave that as your final answer, because anything to the 0 power is just 1. Like you replace the whole thing with just a 1. So anytime, like, don't leave any exponents of 0 in your final answers, okay? And then number 7 involves like a list of numbers or data or scores or whatever, and you have to find like the median, lower quartile, upper quartile, and the interquartile range, and then you have to draw a box and whisker plot. The good thing is a lot of those things you need in order to find the or to draw the box and whisker plot. So take this list of values, for example, okay? And I believe there's 23 values here. So let's say you had all these numbers, and you have to find the median and the lower quartile and all that stuff. Remember, with the median, that means the middle number, and these numbers have to be in order. So make sure your numbers are in order first, and then you got to find the middle number. So in this case, with there being 23 values, so there should be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then the number in the middle, and then another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. Okay, so this 313 right here is the middle number. And so the median here would be 313. And then as far as the, not yet, the lower quartile, remember the lower quartile has like at least a couple other names for it. You know, lower quartile can also be called the lower median, as well as the first quartile. But lower quartile means the lower median, which means you take the lower half of the data, all numbers that are to the left of the median. So all of these numbers, this is like the lower half, and you're going to find the median of just this quote-unquote half. You know, sometimes it's exactly half of the number, sometimes it's slightly less than half. But anyway, see, in this case, it's actually not exactly half the numbers because this number is like the median. So it's not exactly half, but we can still call this the lower half. Anyway, again, the lower quartile is the median of just this lower half. So what is there, 11 of these here? So we go 1, 2, 3, 4, 5, and then the number in the middle, and then 1, 2, 3, 4, 5. Same thing with the upper quartile. You could also call the upper median. 1, 2, 3, 4, 5. Okay, so again, I mean, I hope that's good. Lower quartile is another name for like the lower half median, upper half median, and then the interquartile range. Remember, the word range is in here, which means like it's not the overall range, but it is a range. It's a type of range, but it's just the interquartile range, and that's going to be what you get when you subtract the upper quartile minus the lower quartile. So you can see it is a range. It's just not the overall range, it's the interquartile range. So as far as drawing a box and whisker plot, just remember, like, you always need to have a number line. And if I recall, the overall median, so you're gonna need a few things. You're gonna need all the medians, like the overall median, the lower median, the upper median, and you're also going to need the highest and lowest numbers. Okay, so let's see here. Usually I use all the medians first, so 313, 313, 306, 322. I should just go by 2. 2, 4, 6, 8, 10. Okay, so these little marks are going by 2. So 313 should be like right here. And then 306, 302, 304, 306. And then 322. So it was 306, 313, and 322. And then well, first let's actually draw. So you draw a box. So this is called a box and whisker plot. So here's the box. It starts at the lower median, goes all the way to the upper median, and then we have a line that we draw. All right, at the overall median. Okay, so we just boom. So lower median is where you draw the left edge of the box, upper median, and then overall median. And then the absolute lowest and the, I think it was 329, right? The absolute highest. Yep. That is going to be where you draw your whiskers out to. So that gets, oh, I was pretty spot on there. Whoa! So there's like there's your box and whisker plot. That's it. The whisker, so the box, and here's like the whiskers. Okay. And that should do it. And that should be able to allow you to complete all problems 1 through 7.